Thank you.
In that case, we don't have anything on the agenda. Does anyone have anything that they want to bring up or discuss?
I have a question about something, but I don't know if anyone else wants to go first.
Go for it.
Yes. So, does anyone object to adding something similar to the single multi extension relations, but to expression? And the reason I'm asking is we see more and more Spark special cases, like special expressions, which are probably not common. And we're looking for a way to, like the correct way to implement around that. Of course, expression which might be complex, like with other expressions as sub-expressions, children. And I think the thing we saw until now, which is the most looks like what we want, is what is exists today in relations. So I don't know if like to his opinions, and we might go ahead and do it. So for example, for aliases, we managed to, what we discussed, we managed to do some workaround, but now we saw we need lambda expressions, lambda functions, stuff for high order functions and stuff like that. And I don't know if it exists in other frameworks. I think I don't know. I'm not sure. And this is something which we would probably. So if it does not, we need some way to extend, which would allow us to serialize and then parse such expressions. So, I wanted to hear your opinion about this approach.
So
something similar to. Yep.
So the first question I have is, have you seen the subquery support? That's the one thing that's in there that's complex that might support your use cases, but it may not.
I will look into it.
I think
first of all,
lambdas we've specifically discussed before as would require new things. It's something I think we want, but I agree that we probably don't want to get hung up on standardizing lambdas to prevent moving this effort forward. I can see. So this is something like a map function or something like that, where you're applying, or what is it? You have a list array as your data type, and you apply
it's
function to every single item.
It's for list functions. Yeah. For list I have the functions. Yeah, like filters, like you said. So this what we
I'm not. Yeah, I mean, in principle, it makes sense. I had actually been wondering about something slightly similar, which would be adding named expressions, but that's different. So yeah, what you're describing seems like a reasonable extension point, in the same way that we have it for relations. And if you are communicating between the same system, it'll work. And if you're not, well, then it probably won't work. But yeah, that seems like a good escape valve to have. Longer term, I think we probably do want to standardize lambdas and add support for those list functions. There are other engines. DuckDB supports that. I don't know about Velox, but it is something that I think Calcite has some concept of that as well.
Well, in that case, we can try to do something like that, and then try to generalize after.
Mm-hmm.
Okay.
Oh, Jacques, I didn't even notice you were on.
Yeah, there's several systems that have lambdas, so I think it's reasonable to standardize that.
Okay.
It doesn't dismiss the need for except but yeah.
So we might start with one and then maybe do both, just to see what would be easier. Because we're also trying to finish like a critical mass of features for the Spark, and then we can, be more confident that we are able to express like a complex enough queries, and start bringing it in like we discussed. This is one of the last things we have left, I guess. So see about this. We're saying that it exists in other platforms, which is important, and also it wouldn't hurt to have this kind of extension anyway. Okay.
And I feel like there was a discussion at one point about this on LPR or an issue.
About the extensions or about lambdas?
Lambdas. I could be wrong. I may have taken it a different direction.
We had, I think, even a proposal at one point in time, but it was not fully fleshed out, and we kind of backed away from it before we.
Yeah. So issue 349. There was a bunch of thoughts there, but I don't know that we came to any resolutions. Put a link in there for people wanting.
All right. Yeah, I'm excited to see some of these Spark PRs come through. I think it's something we want to play with as well. So
yeah.
Is there a sense to put some stuff up, because I'm actually on the call in an hour where I think someone's going to about this capability, and I'd love to be able to say I like the patches that are coming soon that'll enable Spark logical interconnectivity or something. Matt, do you have a particular timeline in mind where you're hoping to propose some patches?
Sorry, can you repeat the question?
Do you have a timeline in mind where you're hoping to propose the Spark sort of extraction and layering patches?
No. We need to, like I said, we need to complete all the missing features that we see. And then I don't know how much time it will take, because what we do is we have our own set of tests, of SQL case tests, and we're trying to support more and more features. Some of them are like TPCDS queries, like very big. And then once you covered one thing, you come to you meet the next thing. I think we're very close to finish, like to have a decent amount of like decent coverage on like most of the tests we support today, and then we can start thinking about that. But we're not sure how hard it will be to extract, and we said we want to put it inside the Java repository, right? So I guess it will be quite a lot of work around it. But I think this functionally we are pretty close. But I can't.
Are you guys doing the work in public so I can someone point them at it? Even
no.
Like, are you no?
No, and I'm not sure how much difference. So we have difference from what is in gluten, of course, but not that much. I mean, we did some patches there, supports some missing features that they did not cover, but if someone wants to look at how it's generally, we didn't change anything in the design or anything. Just small stuff like I don't know, to support like var functions, which they didn't have, and small stuff like that. And some of the work is internal, is like our own internal relations, which we will not put in Substrate. If you want someone to look at it, we can maybe just have a meeting or something for now.
Okay. Thanks.
Just for completeness, like the Intel folks, or what they use is the physical plans from Substrate, from Spark. So a lot of the extensions they have built, all the hints they add to the Substrate plans, they are leaning towards the physical plan representation of the Spark.
For some reason, I thought it was one of the logical plans.
They have both.
No,
Gluten
so
use physical, Matt and Teams uses logical.
Yeah, they are not using the
Right.
logical part that they wrote. They even said it in the emails. They are not using the logical part at all. So they stopped. This is why they stopped in the middle, and now we are completing like what we can. And yeah, they only use the physical stuff.
Is there physical stuff going through Substrate, or?
Yeah.
Oh.
yeah, but I think a few plans which we looked at, they're not using the latest Substrate specifications, so some of the things are custom. And in fact, what they do for ClickHouse and what they do for Velox, I mean, in principle, they assume that Substrate has to be different for different engines, which directly conflicts with the Substrate philosophy. Right, like if you're generating engine-specific plans which the other engineers cannot consume, then we break the main goal of having a common representation.
Well, I think there's a certain amount of inevitability here, which is every engine is going to have some clever feature that's unique to them. And therefore, they're going to need, there cannot be a common representation that, like a common, I don't know if representation is the right word, call it dialect for lack of a better word, domain. A common domain of Substrate that's going to maximize every single engine. I think if you have, sort of like, in any time that exists, that particular engine is going to have some kind of planner which converts from something to something that's optimized for their particular engine. And if that, and I think at that point, that planner, if that takes in Substrate, that's good. If there could be layers, I guess. So like hash join and merge join are similar enough, many different engines implement them. And many producers don't. So I don't think there's going to be necessarily one domain spoken at every layer. So I think there's kind of like the bottommost layer. Yeah, that probably doesn't end up, that could be Substrate. It doesn't have to be. There's not much merit in it being Substrate at the end of the day because no other engine speaks that layer. But the top layer is definitely Substrate, and that's where most people are engaging today. And I think there might be a middle layer that emerges over time. That could also be Substrate, but maybe not every producer, not every engine agree on what goes in there, and they use different mixes of different things.
I'm less cynical than Weston is about the lower layers in Substrate's role,
Okay.
but
there's pros, there's advantages, I think, especially if some of these implementations like PySubstrate and C++ Substrate start to offer visitors and transformations and things like that, then there will definitely be advantages to writing those lower layers in Substrate. Those advantages won't be portability necessarily, because you won't be able to take those plans. But then again, if you're a successful engine, people are going to want to emulate you. So your niche optimizations will someday become not so niche.
Well, I think that this has to happen, right? Is that step one is that people are good, and step two is they use it to gain workloads on either direction, right? Like I think you see the storage vendors suspect like trying to adapt the connect existing systems, right? And so I think that as more systems, as we have way more ways to communicate amongst Substrate, there will be a way to get workload. Like that's at the end of the day, if you're an engine, what you want to do is get workload, right? You want to get data, you want to get workload, and so I think that that'll be the ultimate driving force that'll set the dynamics. It's not like right now it's a technical decision. Over time, I think it'll be a like a simplification or like a workload, like being able to access workloads you otherwise couldn't access decision. Which I think is a little bit like what happened with Arrow over time. Right? Like early on, you just used Arrow inside your system. It's like a fast way to read Parquet. But then later on, people were like, oh, this allows me to connect in an efficient way with other systems and take advantage of the ecosystem.
Yeah, and actually going the other direction, I know there are a number of systems for which the logical plan is too complex. So there's, especially with like the storage side of things, there tends to be a lot of focus on scan, filter, project, but not join, because at the storage layer, you're not necessarily trying to do all that much compute.
I'm curious. I didn't actually look at it yet. I saw the news about ByteDance open sourcing their ClickHouse fork. I don't know if you guys saw that. It's called Biconity. Here, let me send the link here. I'm curious whether or not they use Substrate at all. I'm assuming not, but. It seems like an EDW by forking ClickHouse, and some stuff. At one point, they were talking about using Substrate, but there are no files that reference Substrate anyway. Oh, sadness.
All right.
So
do we have
going back
yeah,
to
go ahead.
the so what eventually do you see these physical transformation for Spark also landing into the Java substrate, or is that still going to be a split brain that logical transformation exists in substrate repo and the physical in gluten repo?
I think that you're asking Batan, but I think that the answer is that they're only interested in the logical, so they're only going to do the logical at most. So if someone else got a bee in their bonnet and want to do the physical, then that would be great. I think we all would be happy and accepting of that, but who knows whether that's going to happen.
I think
Like,
it's
hey,
there's a
Ashvin,
lot
if you
more
want to do
missing
it.
for physical. I guess there will be much more work because the physical is of course much richer. It's like tons of different kind of implementations to the logical, so it might be much harder.
You hope one is that Spark actually adopts the physical. moving on to a different topic, if that's okay. I saw that Weston opened a patch a couple days ago about the concept of unknown.
Just an issue, not a patch, but
an issue. Okay.
I can make a PR.
No, I'm not asking for a VR. Which is basically the idea of unbound references. Like, I don't know. I know that there's a field I want. It's called foo, but I don't know necessarily what its type is. Maybe I know what its position is, depending on how you would think about it. I think that one of the thoughts I have is that I had an early conversation with the Spark guys about whatever released is something else. They didn't use Substrait. So maybe 8 months, a year ago. It was like the last day of the II summit. They released something which was called like was an invitation for like Spark plans that was unbound. Does someone know what this thing's called? That would probably be helpful because I don't remember what it's called. Unresolved logical plan, is that what it's called? Okay.
Spark Connect. Are you talking about the Spark Connect where they send the logic and unresolved logical plans from any engine to the Yeah.
Okay, great. Thank you. Everybody knows the name of me. And so I feel like what Weston is proposing is to support a similar pattern. Is that fair, Weston?
Yeah, actually, we have been looking at Spark Connect as well and thinking about how that could get, supported. And that is not where this motivation came from. In fact, I'm less like when I was looking at Spark Connect, I was thinking, well, in order to, the easiest thing to do with unresolved logical plan is just to create a module. You almost need Spark to resolve it enough to turn it into a substrate plan. So I wasn't quite planning on going that far. Like they have, and I'm not as familiar with Spark Connect as kind of, because it would extend beyond expressions, I think. And it would go into the idea of having entirely unresolved relations like there, which I don't know that you need. I think things like named table node and so on could do that. So I'm talking in a circle here. Let me step back.
A blurry circle, no less.
Yes. So that's not the motivation I had. I agree that they are very similar things. The motivation I had was we recently added support in PyArrow for converting PyArrow expressions to and from Substrate on their own using the extended expression message. In PyArrow, expressions are always unbound, unresolved, just because they're strings. They're not actually strings, but they're the user enters them in. These are used at like the highest layer where the user is entering them in and typing in the expression, and so they don't, they don't have access. They're used in a lot of different places, but in a lot of contexts, they're used in an unbound way. So today, you just say, okay, if you want to serialize the substrate, give us a schema, and we can serialize it for you. And so we bind them at that time, and then we serialize it, and that works. And that's probably good enough for 90% of use cases, but there's still the 10% of use cases where, and it's like I put in the ticket, where we're talking about the front end where you're asking the user, what query do you want? And we're just going to send that query to a system that's going to go off and resolve it. And at this front end, we don't have any of the schema information. We're just asking for the query. It's like a an SQL window where you're just asking the user for a string, and you're going to send that across without doing any real analysis on it of any kind. So it's kind of like if you just had a string, you could at least parse it, on the client side into an unresolved or a query with unknown types everywhere, and then send that across. So that was the motivation, was just being able to take pi-arrow compute expressions, which are unbound, and serialize them to Substrate without requiring that the user supply a schema.
Yeah, I think it. The questions come to mind in my head are like this. Is this a new hierarchy that exists, or a new entity, like a new class of, right? Like unbound expression could be like we could have bound expressions and we could have unbound expressions, and all of our current expressions and we have separately unbound expressions, right? Because there are other things like it's kind of one of those things where it's like kind of cutting it like like having done this before in calcite. So there's actually a concept in calcite, I can't remember what it's called, like an unknown type. I worked on that work like 10 years ago. And it's basically like everywhere in the code, you basically add this exceptionality where, like, for example, you're trying to decide whether or not this function can bind, and how you're going to coerce the output type based on the input types. And so every one of those locations, you basically run an if statement, which is like, oh, if one of the types is unknown, then the output type is unknown, or whatever. And so we did it basically in the same hierarchy, if you will. We just said, okay, there's one more type, and it's the unknown type, or whatever we called it in calcite. So that seems like it's one pattern. The other pattern is one where you say, like, hey, this is actually a separate class of things. And, we have unbound expressions, and unbound expressions, for example, can't be used in relations, right? Because only bound expressions can be used in relations. And in the future, we could introduce unbound relations, which only have unbound expressions, right? Like, I'm not arguing for that. I'm just saying that, like, that's there's that pattern is in my head because there are weird things, right? So as an example, right, like how functions work, right? So functions have name resolution today, right? But if you don't have types, you can't resolve functions. So I don't think you would look up functions I don't think you would use function anchors or anything else in this unbound world, because you don't know if add is integer or decimal or string. And so that's the question I have, is like, that's probably the top level question I have. Beyond, is this a good idea? I think it's a good idea. My gut is this a good idea. And then it's like, well, how does it fit? So it doesn't just make a mess of everything.
So how would, if we were going to have a set of unbound relations, does that mean we end up basically doubling all of the implementations?
Probably not, because I doubt you would express. I mean, like, this is, on that spectrum of logical to physical, further out the logical edge, right? And so, like, expressing that you want a hash join of unknown types feels weird, right? Like, if you're talking about something that's more on the physical end of the spectrum, you probably wouldn't say you could actually even express it with unbound types. Yeah, but yeah, no, that would definitely be, I think, a risk if you create a separate hierarchy or a separate class or whatever.
Yeah, and I guess there might be a third sort of middle ground where unbound expressions are a separate thing, but they're still usable within relations. So it's an unbound expression has its own tree, but then you have some kind of the like maybe the top level expression node just has, I don't know, you could, yeah, you'd probably would have to break it into a top level node, which is like a
Resolve
expression
unbound
tree,
expression.
which is either expression or unresolved expression.
I think the other place where this comes up is anything that's doing schema on read, which is useful. Sometimes you do want to tell your engine like, hey, this is an unbound, and for some engines you might be like, oh, you're using it in the join, so you should try and cast this as like a, and having an unbound thing is a good place for someone to go like rewrite the tree to try that operation.
Yeah, I mean the thing that gets the thing you get into, right, is that I went so far out of this path trail. I gotta say, we went so far path and trail. But then there's questions, right? Like, in the unbound expression be multiple types. Right? If I've got two files that are JSON, and I say field A, and the first file, field A is an integer, and one is an array of objects. Right? You get down into that kind of muckiness.
Well, there's a whole set of solutions for that kind of problem.
It
That's
also
what I
feels
said.
like
Yeah, muckiness, exactly.
that feels like the implementation detail for like the engine, where like some engines might be like, hey, if you're giving me a tree, there can't be anything unbound in it because I'm doing like, you know, columnar operations and everything has to be known beforehand. And some engines might be like, sure, I'll try it. And if it fails, you're telling me it's this, I'll try it. If it fails, I'll let you know when I try running it, right? Like there's a range of execution behaviors that can happen.
Yeah, I was even take one extreme, the SQLite model of, oh, you want a column that's a mixture of strings and numbers? Sure.
Look, you gave me
That's
a
why it's
string.
called light.
However, that string looks like an integer, so actually it's an integer, but actually looks like a float, so it's a float. And don't ask me what I do for a living.
But yeah, no, I mean, we do have exactly what you're describing in Arrow, but we still have a common schema that everything has to adhere to at the end of the day. The individual files might have different schemas, but you write all your, you know, the user writes all their expressions against the kind of common, we can resolve everything to this schema.
Yeah, no, it's.
I think I like the idea of unbound expressions being a separate tree, because I think I agree that at each different point in your system, you're either dealing with unbound expressions or you're dealing with bound expressions, and you're not, you know, you don't have like a spot where you're dealing with a mixture of the two. So I hadn't thought of approaching it that way, but I do see some merits there, because that would simplify, like you said, you don't have to have, it's not a special case that you have to consider everywhere. It's you know, these four components are dealing with unbound stuff, and then these components below here are dealing with bound stuff.
It's the thing that I struggle with is the like what defines a valid plan then? Because there's a you can check the integrity of a plan right now. You know, a lot of it has to do with types and record outputs and those kinds of things. And yeah, with the unbound expressions, like even like case statement, right? Like, okay, case statement, the conditions have to be Booleans, right? And the outputs have to be the same type, like the branches of the case statement. And so you're like, okay, well, if I have a bunch of unbound expressions, like none of those rules apply. I mean, they kind of do. Like the case, I mean, they don't, but they do. Like, yes, those things have to be true ultimately at execution time. I mean, that would be an interesting argument, right? Should you be allowed to put an unbound expression, an expression that doesn't claim it's a Boolean, in a case statement, or should you have to put a, you know, like maybe you could have an unbound tree, and in the case statement, and then at the element before the what the case inputs are, right? You have a resolve function which says this is a Boolean type. So if you want to use the function definitions that we have now, you have to resolve your subtree first, right? And that actually happens, right? In unbound expressions, you can have casts, right? Like, oh, the base is nothing, but then I cast it to an integer. Now I know that the rest of the tree is actually a bound expression of integer type. And so it does seem like, you know, if you wanted to have an unbound function type, that would be a different thing. And probably it's just a name, right? It's just a name and some arguments. Like, and we don't verify it against anything. And it's completely separate from the concept of what we have in terms of functions now. Maybe it's a flag in the existing functions. I don't know. It's easier in proto than it is once you start to say, okay, let's layer it out into an object language, right? Because you kind of feel like these things that are not going to be able to return a data type shouldn't be in the same object hierarchy if you're in, you know, an object-oriented language.
I mean, you don't do a lot with unbound expressions except pass them on to the system that eventually binds them. So I get what you're saying.
I mean, this is like, well, in the schema on read case, you do. Right? In the schema on read case, you're still trying to make a decision whether you want to do a hash join, or a merge join with your unbound expression. So there are definitely scenarios where you do. It may be that the examples that you're using in Western right now are not those. But I mean, I've tried to do all sorts of, like, you know, partition pruning on unbound columns, you know, whatever.
Yeah, the case I'm thinking of, you're right. None of that. All we do is, as soon as we actually start a query, we're going to immediately bind it at that point in time. So the only thing that users are really doing with unbound expressions is IPC and composition.
And then there's the resolving step, right? So at some point you need to take in a substrate plan, and you need unresolved substrate plan and resolve it. So that becomes an important step to I guess start getting people used to in our documentation when we implement this.
I'm realizing that we actually sort of do this how it works. We actually have a user-defined type called any, which is literally just like what is in this column. And then in the planning stage, we have various rules around, like, you're trying to fetch this column. We're going to force you to do a cast before we can do any kind of push down for some systems that can't handle like any, which is like a more hacky version, I guess, the unbound thing, because we have to look at the types and can we do this in calcite effectively, because calcite gives us the types in any relation. It would make you can't really resolve it easily in substrate. There's no hook, and you'd have to like propagate the types in your system to figure out what's an unknown. Something like unbound would be useful there to be like, oh, it's unbound here. Like, you're gonna have to tell us what this is. But we are actually doing something like this already.
Some things don't care. Count, it takes an any as its input and always returns an int or an integer. So yeah, I guess that's
Is null, same thing.
Yeah.
Yeah. Some things don't care.
Yeah, I mean, yeah. So yeah, some things tell you the output type independent of what the input type is, which are two different scenarios. Some things have restricted set of inputs, but they define output independent of which of those inputs it is.
So I listed this as an issue mainly so I could link to it in another PR and say, if you care about this, here's the issue to go look at. I don't know that I'm going to run off and implement this right now. It's not high on my priority list, unless someone were to really start complaining and saying this is something we absolutely need. So
Okay.
Yeah.
So I shouldn't have brought it up. All right, good deal.
I should have started there. I literally, the only reason, because I'd been thinking about this and thinking, yeah, we could solve this problem someday in my head for a long time. And then it was like, well, I was creating this PR and I need to say, we can solve this problem someday. You just have to do X, Y, Z. And I was like, all right, I should probably at least create an issue so I could link to that and say, you know, if this is really important to you, go talk about it over here. I think most users have no concept of this. Like, and when I talk about users, I talk about like people authoring queries and using PyArrow, and we've had the difference between bound and unbound expressions in Arrow since the start. And I would guess that a very small number of our users even know that such a distinction exists. By the time it hits like the user API, it's just unbound expressions, and they don't know that they're ever bound to anything.
Yeah, another option here would just be to deprecate that and see what it play, and then worry about it in Substrate.
Well, yeah, we can't deprecate it. Our default is unbound. So users,
Those new version numbers are for. Come on.
Users like to write X plus Y. It's really hard to train them to write X colon I32 plus Y colon I32.
Fair enough. All right, is there anything else everyone wants to talk about?
I thought I would just update everybody on the text format. The latest PR, which pretty much brings us up to be able to handle all the TPCH queries except for the ones that contain subqueries. The implementation is a bit more verbose than it used to be. It requires types to be at when you declare a function, you have to provide the type output type. So some of this explicit binding. I'm hoping to try to fix this some point later on, but not immediately. And the field references often are a little bit more verbose as well. Mostly when you're converting into the text format, because it's easier to, it's like if you had two things that with a column called name, it's easier to refer to one with the schema that it came from. So schema.name. And so it just uses schema.name throughout to make it easier to reference. But it makes it a little bit more verbose. The end result is more verbose than I want, but it works. We can actually take a binary plan, convert it to text, and convert it back to binary, and it's nearly identical. So I'm pretty happy about that.
And where is this at?
I put the link in the notes. It is going to be pull request 78 in Substrate CPP.
One thing I think we're going to look at soon, and when I say we, I probably mean mostly David, is starting to add documentation around how this stuff works.
Yeah, I would like, so it's not, I haven't yet gotten to the point where it's integrated with all of the load functions everywhere in the ecosystem. And that's coming soon. And yeah, and I want to put it on the document. I want to update our documentation on the website to use the text format, so people can see the text format and know about the text format. And while I'm there, I'll probably make other tweaks to the documentation as well, but see what ends up happening there.
I think we had a discussion a long time ago about having more examples in the spec. And one of the challenges of putting examples in the site anywhere is that you can't just put in a binary proto and putting in the JSON is unreadable. So now that we have some text format, one way to start getting feedback on it and introducing people to it could be to start putting those examples in.
I have one more small question, and this is related to, again, Spark and gluten in some sense. If I replace Spark with Postgres, anyone has an experience with those hooks on Postgres? And I think we already have a C++ Spark. Could that be used to convert Postgres logical plans to Substrate?
As much as I use it as a reference, I have no idea how Postgres actually represents their plans. Outside of the few times I've run like explain analyze or whatever. They have a lot of plugins for user-defined functions and types and even plugins that add new relations. So I imagine it must be possible. Are you thinking of like having Postgres accept Substrate or having Postgres produce Substrate?
So I'm thinking the latter, which is Postgres produce Substrate. And the way I'm thinking about is that Postgres has all these hooks at different places which can alter the behavior. You can inject it to change the plans and whatever. So I have a plugin which would get the logical plan and convert it to Substrate. And that allows for like a lot of things, like if you have common tooling for which is based taking Substrate plans as input, then that could be used for everything. So that applies to Postgres also. Just capture the plan and use it, the common tooling on top of it for analysis of queries or how data is getting used and so on.
So you'd almost be using
As an
Postgres as
example.
like an SQL parser at that point.
So Postgres is running as such in its old form. I'm not modifying the plan. I'm just converting to Substrate and returning the old Postgres form as is. I mean, this is to start with just for exploration. I don't have any concrete products, but a solution in mind. But that's what I was curious if anyone has a prior experience with hooks and does this approach make sense?
It's a cool idea.
Okay, I'll give it a shot maybe, and I'll maybe update you guys. But it's like and logical. It's like same as what Gluten is doing with Spark. You capture the plans and convert it to Spark, and then it's in Substrate.
I mean, I'll play devil's advocate a little, which is that in Spark, there isn't a great, like we do have other SQL to Substrate parsers. So we have like DuckDB or Isthmus, of course, which can serve as that role where they take an SQL and they spit out Substrate. So if you were to be able to use Postgres in this way, I don't know that it would have, I think there's some incremental value, which is, I'm guessing Postgres has a few dialect specific things, or maybe their parser and does some planning or something like that. So there's some incremental value, but I don't know how much like brand new value there would be, if that makes sense.
Yeah, it makes sense. What I was trying
or you're
to map
thinking
it
maybe,
was,
yeah, go ahead, sorry.
So the motivation was coming from what Meta is doing with Prestimo and like all the Velox effort, right? That you may have multiple front ends, but the backend execution layer is common, right? So and that's where Substrate fits nicely. That if the backend engines, like even what Meta data, speed data is doing, if Substrate is the input, then the query can come from any front end, essentially. So that is just convergence of the backend layers. It may not provide any other value to Postgres community itself, but for a business, it might make sense.
We are not operating on, so the SQL is not turning into Substrate. The logical plan is what it's what Gluten did, right? They go over the logical plan, not the SQL. The SQL Spark is going Spark SQL to logical plan. By the way, it might not be even SQL. It might be data frame API. In that case, you don't even have SQL, right? And then Substrate is being built from the logical plan.
So would you
So-
care if it is coming from Postgres,
What?
the Substrate plan? The logical plan, if it comes from Postgres, it will still work.
No. What do you mean still work? Like what we have now?
Yeah.
You mean if we have Postgres logical plan to run on like in our system, or you mean in like something like the Gluten plugin? I'm not sure I understand.
Well, I think there's a lot of tools which start by accepting Spark logical plans as their input. I don't
Mhm.
know, and maybe there are, but I don't know if there are a lot of tools that start by accepting Postgres logical plans as their input. But maybe these are the plugins that you're describing. Maybe there are tools out there that accept Postgres logical plans as their input today. Is that
One pitfall that I will call out about using plans from one engine to another is in some cases, engines, the SQL parsers will encode invariants in their plan that are not enforced in any way. So if you send them a different, we ran into this with CalSet recently, where they have if you give them a group by with some keys that aren't like in column order, it will automatically reorder them in its representation, which is only handled by the SQL parser. If you're building them directly, you have to enforce that yourself. So you could run into issues where you generate a plan from Postgres, it violates a hidden Substrate, a hidden Spark invariant that you don't know about. This is something to watch out for.
I see.
but
I think
and then sorry.
go ahead, please.
Just I guess maybe another way to phrase your question to Matan would be, Matan, you're building some tools that accept Substrate, do something, and then they or maybe they accept the Spark logical plan, convert to Substrate, do something, then turn it back out and send it to other tools. Like it sounds like your top layer is all kind of Spark, but you might have some lower level tools which are using Substrate, so they don't have to know about Spark.
This is what we're trying to do today. It's keep really coupled because we start with Spark, and Spark is very coupled to the code generation. This is what we want to accept the Substrate. Get Substrate from so now it gets it from the Spark plugin. And Spark plugin, what it does? So Spark plugin turns the logical plan, the Spark logical plan to Substrate, and then it goes to the code generator. And we want exactly that. We wanted the code generator with no Spark. So then when we move on to other frameworks and try to run queries from other frameworks on our hardware, it would be easier at least. So of course, in the code generation, we need to support sometimes Spark specific features, right? But it will be like a union of all the frameworks, what they can do, and then and also we hope that Substrate would have the union of all the capabilities, and then we can actually do that. We can have the plugins serialized to Substrate, and the code generation would be agnostic of the framework.
So I think that if I take Ashwin's question was, your code generation plugin shouldn't care if the front end was Postgres instead of Substrate, or sorry, Postgres instead of Spark.
Yeah, shouldn't. So I don't know if we will ever get to such like 100% that it would be like that, because you know, there are always special cases and edge cases, but this is the idea. Yeah.
Yeah, and I think that's a very good vision. It makes a lot of sense for a lot of at least service providers and vendors like Microsoft. Even people would like, because there's an ecosystem which people build around the analytical engine itself, like there's governance on top of it, there are policy enforcement. So if there is common engine, a common layer, then front ends encoding their plans in Substrate, and then the rest of the pipeline continues. Makes a lot of sense to me. I don't know if it will become real at any point of time. So I'll start with Postgres as an example maybe, and then we can discuss more. I think there's time, so I don't want to stretch too much. But
Thanks,
yeah,
everyone.
thank you. Thanks for the input. Have a wonderful day. Bye-bye.